Welcome back. In this video, we'll start section 1.3. We'll be talking about linear combinations and span. The goal for this section is to extend the notions of linear combinations and spans from linear 1, where we define them only on Rn, to general vector spaces, so any vector space we like. All right, so let's first review what we did in linear 1. So we want to talk about linear combinations and spans in the Euclidean vector spaces. The goal is to review the notion of linear combination and span in En introduced in linear 1. All right, so we're going to consider En, which means the set is Rn, and I'm using the standard vector operation, so vector addition and scalar multiplication of vector. In linear 1, we define the notion of a linear combination and a span for this vector space as follows. All right, so we're going to start by taking elements V1 through V. It doesn't need to be the same, so let me make that clearer by putting a K here. I'll correct the notes accordingly. So take elements V1 through Vk of Rn. A linear combination of V1 through Vk is any sum of the form A1 V1 plus A2 V2 plus AK Vk, where A1 through AK are real numbers, and then we just scalar multiply and add them. We then say that W, the sum that we get, the vector that we get as a result, can be written as a linear combination of V1 through Vk, or we could also say that W is a linear combination more directly of V1 through Vk. All right, the span of a collection of vectors, V1 through Vk, is the set of all linear combinations of V1 through Vk. All right, so let's write that down. It means that I'm going to take every possible combination using all possible real numbers, A1 through AK, so A1, A2, AK in R. All right, in the next video, we'll be looking at this example 1.3.1, where we'll be writing vectors as a linear combination, and we'll also be describing the entire span.